So on 5-6, Algebra 2, we're talking today about factoring cubes. Before we dig into the problems of factoring cubes, I'm going to make this little table for you. You might want to make this for yourself and stash it somewhere to look at through the rest of this chapter as you do the homework. But there's a lot of problems that we're going to be looking for squares and cubes of numbers. So I'm going to just make a quick table here, and maybe you'll make this yourself somewhere on your quiz when you take a quiz someday, because you can't bring cheat sheets into the quiz, but you can make this on the spot. If we start with just any old numbers from 1 to 10 and make some squares, 1 times 1 is 1, 2 times 2 is 4, 3 times 3, 4 times 4, 5 times 5, 6 times 6, etc., and so on. Making the squares is easy, just things times themselves. To make cubes, you'd have to go triples. So 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3. And since we already did 3 times 3, just take the original number times this. The cube would be 27. The cube of 4 would be 4 times its square. That's 64. The cube of 5 is 5 times its square is 125. 6 times this. 7 times that, 8 times this, 9 times that, 10 times this. And over time, you might by accident or on purpose want to just memorize some of these, the squares and the cubes. When you see these, we're going to want to be able to recognize them when we see them. Today, you're going to be seeing a ton of cubes. You're going to be looking at a ton of these numbers in your homework questions. So step to the left now. Factoring cubes is going to just be based off of a pattern. Okay? How you know you have a cube problem is that the powers have to all be divisible by 3, whether they're 3s or something that 3 can go into, like 6, 9, 12, whatever. The powers all have to be powers that we can divide by 3. And then the numbers have to be numbers from our cube list. So if we have our cube list copied down, 64, 8, 27, those are all numbers that were on the cube list. Okay, so you know you have a cube problem when powers can be divided by 3 and the numbers are on the cube list. I'm not writing that down. You might want to write that down if you don't think you can remember that. Again, cube powers have powers that can divide by 3, and they have numbers that are on our cube list. The way we're going to do this is take the first item, look at its power, divide the power by 3. 3 divided by 1 is just 1, so that's just an A. So the first number, power, divides by 3. Last number, power, divides by 3 as well. So we're just going to get a plain old B. So powers on both of these numbers, divide by 3s, that gets us the first and last thing. If this had been a 30, this would have been a 10, but I didn't do that. If this were 12, this would have been a 4. I didn't do that. I started off easy with just 3s. Okay, but the powers will divide by 3s. The sign is going to just copy. So if this was a plus, this is a plus. That's how we build the first factor. We look at the problem to build the first factor. Power divides by 3. Sign gets copied. Power divides by 3. That's all we need to do to build the first factor. To build the second factor, you don't look at the problem anymore. You look at the first factor that you built. And you might want to write this down. I'm saying things, you might want to write these things that I'm not necessarily writing. To build the second factor, we're going to go first item times itself, and that goes first. We're going to go last item times itself, and that goes last. That will always have a plus, because anything times itself is positive. Negatives times negatives are positive. Positives times positive are positive. Anything times itself, we're going to get a positive number there. In the middle, we're going to go with the different sign from what we had. So originally this had a plus and we copied. Now we're going to go different. We're going to go minus on that. And to make this middle term, we're going to just multiply these together. The first times the second, so the A times the B. That's always going to work. If you don't believe me that it works, you can always check factoring by foiling. If you want to foil this out, 2 terms times 3 terms would temporarily get you 6 terms, but there'd be a ton of opposites that would eliminate. You'd end up back down to this. Like, this would be a positive A squared B. but these, when you FOIL, would make a negative a squared b, and that would just all vanish. Okay, it'll just work. So one more time. If you think you got that pattern, just do this one. If you don't think you got the pattern, just listen into what I'm doing. So I'm going to go first power, first item, take the power, divide by 3. I'm going to copy the sign. I'm going to take the next power and divide by 3, and I build the first factor from the problem. Then I quit looking at the problem, and I look at the answer that I've started to create is all that matters now. First item times itself goes first. Last item times itself goes last, and that's always positive, because negative times negative is still positive. Here I need my sign to be different from what all the earlier signs had been. It was all minuses before. This is going to be a plus to be different from what's before. I don't care about that. That's always plus here. And then we're going to multiply in the middle, take first times second, a times b. The next one has a number. If you think you know what to do, just pause the video, try it, see if you're right. If you're not sure, just listen in. So it starts off about the same way. It's a cube problem because the power divides by 3, and 64 is on our list. There it is, 64. So we're going to take power divided by 3, gets me just an x. I'm not going to write an invisible 1. The sign gets copied. And now we deal for the first time with the number. Okay? What we need to do for the numbers is cube root them. We're going to cube root the numbers. By cube root the number, I mean use this chart. Take 64 and track it back to where it came from. It came from a 4. 4 times 4 times 4, 4 cubed is 64. So cube rooting just undoes cubes. Cubing turned 4 into 64. Cube rooting turned 64 back into 4. So 4 is my number there. 64 creates a 4. Then quit looking at the problem, start looking at the answer that we've started. Only this is used to build the second factor. First item times itself is that. Last item times itself is a 16, always a plus there. This sign, we just need to be different from what had been there. We had a bunch of minuses, so we're going to go plus now. And take the x times the 4, it's just better looking as 4x than it would be x4 just looks weird. If you think you got it, go ahead and try the next one on for size. All those numbers are going to have to get cube rooted. Use the chart. The powers will have to get divided by 3, and we'll do it that way. Okay, but 8 is going to turn into 2 because this says so. This says that 8 should turn back into 2 when we do the cube root. X's power should divide by 3. 3 divided by 3 is a 1. The sign gets copied, so plus. 27 needs to be on our list, and it is. So 27, we backtrack that into a 3. For the y's, we need to divide the power by 3 and get a 2. So again, process is every number gets cube rooted. 8 and 27 made these numbers. When we cube rooted them, we just reversed this chart of facts. And the powers in this first factor, we're going to divide the original powers by 3. Then quit looking at the original problem. Only look at the factor you made. First item times itself. 2x times 2x would make a 4x squared. Because 2 times 2 is 4, but x times x is x squared. If we make this just a little bit longer, at the end we'll get a plus always. 3 times 3 is 9. Y squared times y squared is y to the 4th. When you multiply with powers, you add them up. If this had been like a y5, 5 and 5 would add up here to be a 10. So like if the original problem is 15, divide by 3 to make a 5. When you do the next step, 5 would jump up to 10. Minus here to be different. And then multiply these together. 2 times 3 is 6. There's an x there, there's a y squared there. Just jump that all in there together and we're good. One more problem. If we try to take this one on right now, you can't do it. Okay? You can't do this right now because the powers can't divide by 3. 125 is a friendly number. And so 125, we're probably going to be able to make a jump in a second from the 125. but these powers aren't right for us. So we're going to have to do an old thing. If you know what to do already, do it and finish the problem. If you don't know what to do to get this started using an old idea, think about it. Pause, think about it for 60 seconds. If you were here in the room, I would just sit here and stare at you until somebody came up with this answer. But there's something we can do to make this problem look better right from the word go. So what that is, we always look first, if you have any kind of a common factor, a GCF, something that's on both of these, we look to take it off. Okay, so these both have y's. So what we need to do before we do anything else is take off a y. None of those questions over there did that, but this one does. We can take a y off of both of these. This then downgrades the y to the third, plus this is 125. In our final answer, the y is still going to be there, but the problem that's in parentheses is just like the ones we did over there in that other column. If you find this to be distracting, the fact there's stuff in parentheses, just erase the parentheses, erase the y. We know that y is going to be in the answer. It's been handled. You don't have to copy it in every single step if you don't want to, because maybe you find that just distracting or bothers you. This now is an exact problem like what we had over there. So take a second and finish it now if you didn't already, just to make sure you know what you're doing. Power is going to divide by 3. Copy the sign. 125, cube root it. Use the chart. 125 jumps back to 5. And then we're only looking at the first factor to build the second factor. The first item times itself. The last item times itself. In the middle, a new sign to do a minus to be different. And just multiply them together by 1. And we're out. Homework off of this is page 231, working from 1 to 21. That's it.